Okay, this is video number 2 in the volumes using the disk method series, and we're looking at example 2 where we have the equations y equals x squared plus 1, x equals 0, and y equals 5, and we're going to take the area that is bounded by the three of those and we're going to revolve it about the y-axis. Okay, so let's go ahead and sketch the area problem first, as we did in the previous video. We have the equation y equals x squared plus 1, so that is a parabola that starts here at y equals 1, opening upward. And we have x equals 0, so that is the y-axis. And then we have y equals 5 as our third boundary. So the area in question is this right here. I'm going to go ahead and label this intersection point. When y is equal to 5, we get that x is equal to 2. Okay, and now we're going to take this area and we're going to revolve it about the y-axis. Okay, so there is the area problem. Once we have sketched, or once we have revolved that about the y-axis, our figure then, our three-dimensional problem, looks like this. Okay, so that's the volume that we're looking for. Now, if we are to go ahead and look at a cross-section of our three-dimensional figure, our disks will be facing this direction this time. Okay, so there's our cross-section. If you can kind of visualize that being a disk, it's not a very good drawing. Okay, now, remember from our previous example, we want to just take the volume of one cross-section and then we want to accumulate a whole bunch of them, which means that we'll take an integral. Okay, so if we are looking at this disk, it's a cylinder, which means we need to know, one, what is the height or the thickness of each of the disks, and then two, what is the radius. So when we're looking here, we can see here that the height of our cylinder, which is the same thing as how thick each of these cross-sections are, this is now measured in terms of y, so this is going to be a dy problem. And then two, going off of the original area in which we revolve, that's where you're going to pull your radius from. So our radius is measured right here. And that corresponds back here to the original area problem. Okay, so here we're going to go ahead and label that as radius. And our radius, we are measuring this distance along the x-axis, so we are looking for the x value on the right minus the x value on the left. Okay, so again, you can kind of see how this is very similar to what we did back in the area section. Okay, so x right minus x left means we need to have a function that is solved for x in terms of y. Okay, so x right is just this parabola. Okay, so we want to take our equation from the beginning, our y equals x squared plus 1, and we want to solve that for x in terms of y so that we have x equals. Okay, so doing that, we're going to get the square root of y minus 1. And then x left, well, that is just this value right here. So that's just always going to be x is equal to 0. So we're subtracting off 0 for the x left. Okay, so now that means our radius is just the square root of y minus 1. Alright, so now going ahead to set up our integral for volume. Remember, volume is equal to pi r squared height for a cylinder, and we're going to accumulate all of those. So pi is a constant, we pull that out to the front, times the sum of our radius squared. So we have square root of y minus 1, and we're going to square that for radius squared, times the height of each cylinder, or the thickness for each cross-section, which this time is measured in terms of y, so that's times dy. Okay, now our limits of integration, those have to be y values because we're integrating with respect to y. We have to make sure that our limits are also in terms of y. Okay, so for our limits of integration, we are starting on the y-axis here at y equals 1, and we're going up to y equals 5. So 1 to 5 will be our limits of integration. Okay, and again, you guys can do the multiplying out and the integrating to go ahead and finish that out. So to check your answer, you should get another 8 pi for your answer. And they're not all 8 pi. You would get a lot of answers that are 8 pi. They are not all 8 pi though, so go ahead and work that out. Make sure that you are able to get 8 pi.